My name is Clint from GSI Technical Support. Today's video is focused on troubleshooting the loss of flame lockout circuit on a standard heater. This video applies to all GSI standard heaters manufactured since 1991. This includes models VHS, CRH, and Chi-Town heaters. This service is of moderate difficulty and should be performed by a GSI dealer or qualified electrician or gas technician. Before you begin, please read the relevant GSI user manuals and follow all safety guidelines outlined, including the usage of personal protective equipment and lockout-tagout procedure. We have a video dedicated to illustrating proper lockout procedure. You can find it on our website. Before we begin troubleshooting, let's take a closer look at the control circuit and flame switch used on standard heaters. Notice that I use the term flame switch and not flame probe. Standard heaters use a flame switch for flame sensing. Inside the flame switch's heat-treated housing is a set of normally closed contacts that open when the housing temperature reaches a temperature of 250 degrees Fahrenheit. Let's look at how the flame switch affects the control circuit. Here's the schematic diagram for the standard heater controls. When the flame switch is wired to the coil of the time delay relay, it becomes part of a flame monitoring safety circuit. The first step in troubleshooting the circuit is to verify the incoming power source. In this case, the power to run the heater comes from the fan. The fan must be running before any power is supplied to the heater circuit. In the diagram, the incoming power can be measured across L1 and neutral. L1 goes through a fuse, the heater on-off switch, the housing high limit, the transition high limit, and the thermostat before it is connected to terminal 1 on the terminal strip. Neutral is connected to terminal 8 of the terminal strip. Locate the 8-position terminal block within the control box and identify the terminals. With the fan running and the burner switch turned on, use a voltmeter set to AC volts to check for power. Put the red probe of your voltmeter on terminal 1 and the black probe on terminal 8. You should read approximately 120 volts AC. Be particularly careful when performing this check, since power will not be locked out during this step. If you do not have 120 volts AC, we can diagnose the reason using the wiring schematic. Look at the wiring on both L1 and neutral on the schematic. The N, or neutral, shows a wire going directly to terminal 8. Unless the wire is broken, there is little here that can cause a problem with the incoming voltage. L1 is a different story because of the 5 components between L1 and terminal 1. Remember, there is a fuse, an on-off switch, a housing high limit, and a thermostat. If any of the components has an open circuit, you will not have a connection from L1 to terminal 1. Check the wiring and components between L1 and terminal 1 and replace any failed hardware. Now that we have incoming power across terminals 1 and 8, let's take a closer look at the flame switch and time delay relay circuit on the schematic. Here you see the actual flame safety circuit. The circuit consists of a 30-second time delay relay and the flame switch. If you look at terminal 2, you will see that it connects the incoming voltage from terminal 1 to one side of the coil in the 30-second time delay relay. Now, look at terminal 5. Terminal 5 connects the incoming neutral from terminal 8 through the normally closed flame switch to the other side of the coil of the 30-second time delay relay. Because the flame switch is a normally closed switch, there is power applied to the coil when the heater is turned on. Looking closer at the time delay relay, notice that it has 4 terminals. The coil is across terminals 3 and 4. The neutral is connected to terminal 2, and there is an internal normally closed switch across terminals 1 and 4. Because the internal switch across terminals 1 and 4 is normally closed, power is sent to the gas solenoid when the heater is turned on. Here's where the flame safety and the 30-second time delay relay come into play. Anytime power is applied across terminals 3 and 4 of the time delay relay, it begins a 30-second timer. The heater has 30 seconds to detect flame, and if it does, it will continue to operate normally. Remember the coil inside the time delay relay between terminals 3 and 4? For the system to operate normally, we must disconnect power to that coil before the 30 seconds expires, because once the coil has power for 30 seconds, the internal contacts open, gas solenoid loses power, and the heater shuts off. How do we disconnect power from the coil? Look once again at the voltage path to the 30-second time delay relay. The neutral side of the power source goes through the normally closed contacts of the flame switch. The contacts inside the flame switch open when the temperature is hot enough. When the contacts open, the power to the coil is disconnected, and the switch inside the relay stays closed, allowing power to the solenoid. Tips and tricks. The flame switch contains a normally closed set of contacts that open when the switch temperature reaches 250 degrees Fahrenheit. Once a burner has power, it has 30 seconds to heat the flame switch to 250 degrees Fahrenheit and open the internal contacts. A flame switch mounted too close to the burner can result in premature failure. Moving the flame switch a short distance further from the burner should be the first step to resolve this issue. That completes our service video on VHS, CRH, and Chi-Town standard heaters. We hope that you found this information helpful. Thank you for watching, and look for more videos on GSI products in the near future.